previously, we obtained the correct rules for transforming velocities from one frame to another frame using the Lorentz Velocity Transformation, or also known as relativistic velocity addition. So this time we're going to solve problems involving Lorentz Velocity Transformation. So this is the first problem. The first problem goes this way. A spaceship takes off Earth and travel with velocity of 0.8 c along x-axis. It then releases a space probe straight ahead that moves a velocity of 0.95 c with respect to the spaceship. So calculate the speed of space probe with respect to Earth. Wait, so here, Earth is the rest frame or the S frame, and the moving frame, the S prime frame, is the spaceship. And the speed of the spaceship relative to Earth is 0.8 c, and the event in the frame, S prime frame, is the moving space probe, whose velocity is 0.9 c relative, that is what is observed speed in the spaceship. It's 0.95 c, so we have V prime. 0.95 c or 95% of the speed of light in vacuum. So, what is the speed of space probe with respect to Earth? What is the speed of the space probe observed by the observer here on the rest frame, which is Earth? So we're going to use this equation, V, since that is the speed according to the rest frame, the S frame, that will be equal to V prime plus U. We have plus U since the moving frame and the space probe, the event is moving along the x-axis, so we have positive U, over 1 plus U, the speed of the moving frame with respect to S frame, times V prime over C squared. So V prime here is 0.95 c, U is 0.8 c. We have V, or the speed of the space probe relative to Earth, will be V prime is 0.95 c plus U, the speed of the moving frame, that's 0.8 c over 1 plus 0.8 c multiplied by 0.95 c, okay, all over the speed of light squared. So let us calculate the speed of the space probe relative to the rest frame, which is the Earth. Right? So the speed V, the speed of the space probe relative to Earth is 0.99 c. Okay, so this is correct since the speed here is not greater than the speed of light. So that is problem number 1. So problem number 2 goes this way. A space train moving away from Earth with a speed of 0.7 c, that is 70% of the speed of light in vacuum, fires a missile with velocity of 0.9 c, and that is 90% of the speed of light in vacuum with respect to the space train. So find the velocity of the missile relative to Earth. If the missile is fired in the same direction as the velocity of the space train. So the missile must have a positive direction since it is in the same direction to the moving frame. Letter B, we will find the velocity relative to Earth if the missile is fired in opposite direction of the motion of the space train. So V prime there must have a negative direction since it is opposite to the direction of the moving frame, the space train, right? So velocity V, that is speed relative to Earth, will be the speed U, that's the moving frame, plus minus V prime. V prime is the moving, the speed of the event in the moving frame, over 1 plus U plus minus U V prime. over c squared. So I'll put plus minus since it depends, v prime depends on, the sign of v prime depends on the direction of the event. So let's proceed to letter A. So we have, since the missile is in the same direction to the moving frame, then we have v equals u plus v prime over u plus, no, sorry, that is 1 plus u v prime over c squared, right? So what's v prime here? That's v prime is the missile, which has a speed of 0.9 c, and u is 0.7 c, right? So let us solve for letter A. So that's v equals, what is u? That's 0.7 c plus 0.9 c all over 1 plus 0.7 c times 0.9 c all over c squared, right? So v in letter A, that is, what if the speed of missile, if the missile is in the same direction to the space train. Let us solve. 0.7, we'll use calculator, plus 0.9 divided by 1 plus 0.7 times 0.9. That is equal to what? 0.98. Okay, 0.98 c. Okay, again, it does not move greater speed greater than the speed of light, right? So letter B. So what if the missile is fired in the opposite direction of the space train? So we'll use v equals u minus v prime over 1 minus u, right, times v prime over c squared. So v here, what is u? That's 0.7 minus c minus 0.9 c all over 1 minus 0.9 c times 0.7 c all over c squared. So v in letter B, for the speed of the missile when it moves in opposite direction of the space train. Let us solve. That is negative 0.5 c. So negative, why negative 0.5 c? It indicates that the speed, direction of the speed of the missile is in opposite direction to the moving frame, which is the space train. So this is problem number 2. Alright, so let's proceed to the next problem, problem number 3. And problem number 3 goes this way. Spaceship A, this is Spaceship A, traveling at a speed of 0.c in the positive x direction relative to Earth. So this is the observer in Earth. The speed of C, Spaceship A is moving in the positive x direction, the speed of 0.7 c. Spaceship B is traveling at a speed of 0.85 c in the x direction, negative x direction relative to Earth. Okay, so if this is the observer in the Earth, Earth is the rest frame, spaceship is moving to the right, so it's moving in the positive x direction, and spaceship B is moving in the opposite direction, okay, opposite direction of the spaceship A, so it's moving to the left relative to Earth. Okay, so this is the observed speed of spaceship B relative to Earth, and this is the speed of spaceship A relative to Earth. So question is, how fast is the spaceship B moving as measured in spaceship A's reference frame? Right, so we're gonna solve V prime here. v prime, since spaceship is a moving frame. So what will be the uh, observed speed of spaceship B relative to the spaceship A? If spaceship B speeds relative to Earth is negative 0.885 c. Okay, so we're going to solve for V prime. So V prime, since B here is moving in opposite direction, to negative direction, then we have V. Okay, we have negative V minus the speed of the moving frame. Okay, this is spaceship A is the moving frame, over 1 minus uv over c squared. Right, so you have minus. Then v, what is v here? Negative 0.85 c all over spaceship. The moving frame is u, and that is 0.7 c. Okay. Oops, I put negative here. Okay, so let us solve. B is negative 0.85 c minus the speed of the moving frame, which is 0.7 c all over 1 minus, okay, u is 0.7 c, right, multiply by negative 0.85 c all over c squared. So the observed speed of spaceship B relative to spaceship A is 0.97 c. Okay. That is negative 0.97 c. So it means it's moving along the negative x direction, right? So again, the spaceship B, speed of spaceship B relative to spaceship A is negative 0.97 c, or that's 97% of the speed of light along negative x direction, right? Thank you.